So continuing with our adventures through the circles, we're going to look at arcs and sectors. Let's go! So the first thing we need to do is talk about theta. Theta is a symbol. It is a Greek letter. It looks like a zero with a line through the center of it. And it's used in mathematics to stand in for an angle that we don't know. So overwhelmingly, any formula that involves an angle from now on will use a theta to stand for it. Now, if we imagine if we had a circle with an angle of theta taken out of it, the question would be, what fraction of a circle do you have? Well, what would the entire circle be? The entire circle would be 360 degrees. But we haven't got 360 degrees, we've got theta degrees. So the fraction of circle that we've got in this sector is theta out of 360. Now, for example, if theta was 90 degrees, then we'd have 90 out of 360, and that would be a quarter of a circle is what that simplified to, which I think makes sense. You know, a 90-degree corner, that'll give us a quarter circle. If we had 120, that would give us a third of a circle, and so on. So it's just a case of how many times does my angle fit into 360. Now, what can we do with this? Well, we can find the area of a sector because we know what fraction of a circle it is. Think about how we've been finding areas of, say, semicircles. If I say I've got a semicircle, then we know we just need to do a half times pi r squared because that's half a circle. So more generally, if I've got this angle, theta out of 360 of a circle, then I just need to do that times pi r squared to find the area of a sector. So we're going to now look at trying to apply that. So let's start off with some relatively non-calculator cases. We want to give these answers in terms of pi. So area is equal to theta over 360 times pi r squared. So let's fill in the bits we know. We know theta is 40 on this first example. 360 is obviously not going to change. Times pi. And then what's the radius of this circle? Well, if you think about it, the full circle would look something like that. I mean, less like a potato than that, but still something like that. And that 16 centimeters does actually represent the radius, because the diameter would be another 16 centimeters again. So we're going to use 16 for our radius. Now I'm simplifying this a little bit, because 40 goes into 369 times, and 16 squared is 256, but we can't really simplify it any more than that. This would just be 256 pi over 9. And we should say centimeters squared because area has units. You can't really make that any simpler without putting it into a decimal, and the question does say put it in terms of pi. So you should try the question on the right. Pause the video now. I'm going to show you the answer in 3, 2, 1. And there's what we should have got. 18 pi over 5. Just plug into the formula and work it through. Okay, what else can we do? Well, we could find areas in terms of rounding to decimal places. Same formula though, so we're not going to do anything too special here. So 19 out of 360, because our angle is 19, times pi times r squared, times 4.2 squared. Stick that in your calculator, and we'll get, rounding to two decimal places, that the area is 2.92 meters squared. Okay, you have a go at the one on the right. I'll show the answers in 3, 2, 1. And there you go. Should get 191 centimeters squared. To two decimal places, I'll just include them as well. Okay, so what else can we do? Well, we could run the formula in reverse. We can use areas that we already know to work out lengths that we don't. So just bear in mind that this x here, that's the radius of our circle. So let's go through an example here. We write in what we know. So theta is 115 out of 360 times pi, and then we don't really know radius, so we're just going to have to write x squared there. And that is equal to 20, because we're told the area of that sector is 20. So what do we do? How do we rearrange this? Well, I think the sensible approach, and you can do this in less steps if you want, but I'm going to multiply up by the 360 first. Okay, So I'm going to leave myself with 115 pi x squared on the left hand side, and if I times up by 360, I'll get to I think 7,200. Yeah. Then what would we do? Well, we divide across by the 115 pi. So we times by 360. Now we're going to divide by 115 pi. And if we do that, we're going to end up with x squared being 19.93 dot dot dot. But we don't want x squared, we want x. So our last step should be to square root that answer. And we're going to end up with x being 4. Let's go 2 decimal places, shall we? 46 centimeters. So try the one on the right. Unpause when you're ready. I'll show the answers in 3, 2, 1. And there we go. We should have 20.78. Okay, so at the risk of repeating myself, what else can we do? So in this question, we don't know what theta is, but our approach is going to be, broadly speaking, exactly the same. We're going to write out the formula, and we're going to fill in the bits that we know and leave the bits that we don't. So we don't know the angle this time. We do know pi, and we do know r squared. So we can say pi times 8.5 squared, and that's equal to the area of the circle, the sector, 62. First step here, well, we're going to do two things actually. I'm going to work out what 8.5 squared actually is. So that's 72.25 apparently. And I'm also going to multiply across by this 360. So I'm going to do my 62 times my 360 on the other side and get that this is 22,320. And then if I want to find theta, all I need to do is I need to divide by that 72.25 pi, or by that 8.5 squared pi if you'd rather. Stick that in and we'll get the angle is 98.3 degrees. Kind of makes sense given the diagram that that's obviously more than a quarter of a circle, so it's more than 90 degrees. It's less than 180. That feels about right. So I'd like you to try the one on the right. Unpause when you're ready. I'm going to show the answer in 3, 2, 1. So did you spot what the sneaky bit is here? The angle they want isn't inside the sector, it's outside the sector. So you'll get that the angle inside is 247.8. But if we actually want to get theta out of that, we're going to have to take that away from 360. So if we do that, we'll get ourselves to 112.2 degrees as your actual answer. Very sneaky. Okay, so that's enough about sectors. What about arcs? Actually, I think I said that too soon. One more question on sectors. This is the toughest GCSE question I could find based on what we can do so far. We've got a shape here that consists of two equal squares, we can see they are here, and two sectors, which we can see are here. We want to find the area of the whole thing. So obviously we need to find the area of these four parts and add them together. Now 1 and 3, they're just squares, and squares we just go 8 times 8 is 64, and there's two of them. So put together, that's 128 centimeters squared. That's not difficult. But what about 2 and 4? Because we don't really know anything else. We do know the radius of the shape, because these are squares, so side lengths are the same. So the radius of both these sectors is 8. What else do we know? Well, we don't know the angle, and we don't know the area. So there's two things we don't know, which generally means we can't really solve anything. But here's what we can do. We know that all of these angles together have to add up to 360. We also know that two of those angles are 90 degrees, the ones in the squares. So the other two angles put together equal 180. Now there might be any particular split, there might be 60 and 120 or 80 and 100, we don't know. But we do know they add up to 180, and that's good, because it means if we put 2 and 4 together, if we were to just rotate them both around, we would end up with a circle of 180 degrees. In other words, a semicircle. So we don't really need to use the sector area thing at all here. We can just say that put together 2 and 4 and you've got yourself a semicircle with radius 8. So let's just do that. Pi times r squared, and then it's a semicircle, so we want to do a half of that. What will that give us? It gives us 32 pi, or possibly 100.5. Let's go to decimals this time. 100.53 even centimeters squared. And so all we've got to do for the total area, add those two up, 228.53 centimeters squared. But yeah, quite a fiddly little question, that one. Big fan of it. Okay, anyway, let's actually look at arcs then. So, when we were talking about the area of a sector, we mentioned that it was a fraction theta of 360 of a circle, and so the sector area was a fraction theta out of 360 of pi r squared. And the same's true for the arc length. This is a fraction of the circumference, and it's the same fraction, it's still a theta out of 360. So all that's really changed in the arc length formula compared to the sector area formula is that we're now multiplying by circumference. We're multiplying by pi d rather than pi r squared. Okay? So let's actually use this. Want to find the length of this arc again. I'll do the one on the left, you have a go at the one on the right, and we'll see if you're right. First one, just put some numbers in. Theta is 14. So 14 out of 360 times pi. And then what's the diameter of this circle, do you think? Well, if we think about this little sector we've got here, then it's part of, obviously, of a much bigger circle. And then the diameter of that circle is going to be 16. It's going to be 2 lots of these 8. So we have to make sure that if it is a radius we're given, that we double it and pick the diameter of 16 instead. So let's plug that in, and we'll get that your arc length there is 1.95 centimeters. Pretty small, but it is only 14 degrees, so it's only like a 25th of the actual circumference. Have a go at the one on the right then, and unpause when you're ready to check. I'm going to show the answers in 3, 2, 1. And there we go, 49.74 centimeters. Don't forget your units. Okay, so what else can we do? Well, we could find the length of the arc in terms of pi. So we're just trying to find this distance here. Let's stick it in the formula. So theta is 36 out of 360 times pi, and then the diameter, don't forget to double, is 140. So that will give us a tenth of pi times 140. Gives you a total of 14 pi. Don't forget units, centimeters. Have a go at the one on the right, and I'll see you in 3, 2, 1. And there we go. Do remember it's got to be in terms of pi. You could also have pi over 5 centimeters. I'm not sure which one of those appeals to you more. I like 0.2 pi. Just feels right. Okay, so what else can we do? Well, we can, instead of just calculating arc length, we can calculate perimeter. It's really important you read these questions and make sure you know exactly what they want you to do. Perimeter is not just the arc length, it's going to be plus the 2 straight sides as well. So let's just do those in a different color. So if we're doing this one on the left hand side, I'm going to find the arc length. I'm going to do what we did before, so 144 over 360 times pi, and then the diameter is 46. And because the question mentions decimal places, we should give this 2 decimal places. So it's 57.81, just about, centimeters. And then we obviously want, it's basically 2 radiuses, isn't it? So we're going to go 23 times 2, that's 46 centimeters. So for our total perimeter, we'd add those together and we get ourselves to 103.81 centimeters. Cool. So you try the one on the right hand side, please. I will unpause and show the answers in 3, 2, 1. Should have got yourself to 17 0.52 centimeters. So, what else can you do? Well, we can rearrange things to find some missing lengths. So, on both of these questions here, we're trying to find the radius of the circle. So we're going to do that by finding the diameter using the formula and then halving it to get the radius. So what do we know? Arc length, that's 50, equals theta over 360, so 20 over 360 times pi d, so times pi, and let's just leave it as d. What could we do from there? Well, something I like to do is obviously get rid of fractions, so we're going to multiply everything by 360. That'll give us 18,000 is equal to 20 pi d. And then, just like we did before, we're going to divide across by everything but d. So we're going to divide across by 20 pi. And that'll give us that the diameter of this circle is 286 centimeters. Seems pretty big, but I think it's right. So our actual value of x is going to be half of that. It's going to be 143, and if we remember some units as well, it's 143.2 centimeters. So once again, I'd like you to try the question on the right-hand side, and unpause when you're ready in 3, 2, 1. And again, they try and pull a little sneaky something over here by giving you the 325 degrees, which is the angle outside the sector. So we need to subtract that from 360 and use the 35 inside the sector. If you use that, you'll get yourself to 139.5. If you don't use that, you'll end up with a much smaller answer, which is not correct. Okay, so what else can we do? Well, we can find missing angles. So let's see how we can do that. Use your formula, theta over 360 times pi d. So pi, and we know diameter is 54 in this first case because it's going to be double that radius we can see. And we know that's equal to 56 because the arc length is 56. So what do we do from there? Well, same as we've normally been doing. Let's times across by the 360 before we do anything. Get rid of those nasty fractions. We'll end up with 54 pi theta on the left is equal to 20,160 on the right. And then we just need to divide by that 54 pi. If we do that, we'll get that our angle is 118.8 degrees. And again, that looks about right. That is clearly more than a 90-degree quarter circle. It's clearly less than a 180-degree semicircle. So even though it's not going to be drawn 100% accurately, that matches roughly the sketch of the drawing. So again, I'd like you to try the question on the right-hand side. I'll unpause the video with the answers in 3, 2, 1. And we'll get there. The theta is 335.6. Again, that looks about right. That is clearly more than a 3/4 circle. And a 3/4 circle will be 270 degrees. So yeah, we're in the right area. Okay, one last question to look at. The most challenging question I could find involving arc lengths and sectors. Nah, it's just giving you a perimeter and asking you to find a missing angle. So what have we got to be careful for here? Well, this is perimeter, which means it's all of the distances added together. So we have to think about the fact that there's these two 5.3s are part of it. And the first thing we should do is take that away from our 22.81. So we'll get that the arc length is just equal to, take away 10.6, so 12.21. And after that, it's more or less the same as what we were doing on the previous slide. We're going to use that 12.21. We're going to set it equal to theta over 360 times pi times d, so diameter is 10.6 in this case. And then we're going to do the same as we did before, which is to multiply across by 360. It's going to be a decimal, but a decimal that we can handle. And then we'll divide across by that 10.6 pi. And we'll get ourselves to theta is 132 degrees. It's like 131.99, but I think we can round that up. Okay, last task, I'd like you to try and do the same with the question on the right. Unpausing with answers in 3, 2, 1. So can you see the problem here? We don't know what x is, and we're given a perimeter of 40. So we're actually going to have to start by saying that the arc length is 40, take away those two radiuses, take away those two x's. And then we kind of have to say, well, okay, what do we know? We know the arc length is 40 minus 2x. We also know theta is 250, so we can say 250 over 360. And then what's pi d? Well, if the radius is x, then the diameter is double that, is 2x. So we're just going to have a 2x pi floating around here. So what do you do from here? Well, let's start by timesing everything by 360. I feel like that makes everything nicer. So there we go. Remember to multiply both of the numbers by 360, both the 40 and the 2x. I've also expanded that term on the right hand side, so I've just done 250 times 2 to get the 500 pi x there. Okay, so what now? Well, we want to find x. So this is essentially a Meckford question, and we've just done the expand step. So the next step is going to be to collect our terms together. So 14,400 is equal to 500 pi x, and let's add that 720x across. What do we do next? We factorize, we take out that factor of x. So 500 pi plus 720. And what's our last step? It's our d, it's our divide. So we're going to say that x is equal to this 14,400 divided by this 500 pi plus 720. So let's type all that in. And we'll get there that x is 6.29 centimeters. What a question to finish this topic. Okay, next up's coming, I think, segments. They're pretty good. They're pretty good. Look forward to them. I'll see you then.